So hello dear students, today we'll solve worksheet problems of current electricity. The problem number one is an electric bulb draws a current of 0.8 ampere, works on 250 volt on an average 8 hours a day. If energy costs 1.50 per board of trade unit, you have to calculate the monthly bill. So students, here we have to calculate monthly bill. So here monthly bill. So for calculating monthly bill, first we will calculate electrical energy consumed. And students, we will calculate this in the unit of kilowatt hour because the commercial unit of electrical energy consumed is kilowatt hour. And here they are asking to calculate monthly bill. So here, what is the formula for it? It is power in watt into time in hour. What do students? We want power in kilowatt. So what here we will do? We will convert this into kilowatt. So how to convert this into kilowatt? 1 kilowatt is equal to 1000 watt. So 1 watt is equal to 1 upon 1000 kilowatt. So here, your electrical energy in the unit of kilowatt hour, it will become power in kilowatt into time in hour upon 1000. So now, so students, here current is in ampere and voltage is given. Power is equal to what? Voltage into current. So students, if we will calculate from the units given in question, then you will get power in watt, and you have to convert into kilowatt. So you multiply by 1000. So here, how much is power? Sorry, how much is voltage? 250 volt. Uh, First, we'll write the formula for power, voltage into current into time upon 1000, and it is in kilowatt hour. So here, how much is voltage? 250 volt. Current is 0.8 ampere. Time is how much? 8 hours, and it is in kilowatt hour upon 1000. So here, if you will calculate this, how much it will come? 0 gone, and you can write here 25 4 ja. It will be 100, and 4 2 ja. It will be 8, and here it will become 2 into then 8 upon 10. Here it will become 16 upon 10. 1.6 kilowatt hour. This. Now next, what will happen? So power we have got, sorry, electrical energy consumed in kilowatt hour, we have got 1.6. This we have got. Now next. Now friend, next is a bill. So how to calculate bill? We will calculate electrical energy per kilowatt hour into unit. So here rate of unit 1.6 kilowatt hour into how much is the rate of unit? It is 1.50. So here it will become 1.50 rupees per kilowatt hour. So here students, it will become 16 upon 10 into 150 upon 100. And here if you will calculate this, 16 0, 16 5 80, 0 8, 16 1 just 16, 8 24 upon 1000. And here student 1 2 3. So here you will get 2.4. Here you will get 2.4. So this is the correct answer. Now next. Next student, they are asking 30 bulbs are connected in series. How many bulbs? 30 bulbs are connected in series. And if one bulb is fused, if one bulb is and the remaining 20 bulbs are again joined in series and connected to the same supply, will the light increase or decrease in the room? So here friends, voltage is same. And one bulb is fused and 29 bulbs are connected in again in series. So here friends, one bulb is fused, and if 29 bulbs are again connected in series, so total resistance will what it will become? It will decrease. And if resistance will decrease, then what will happen? Current will increase. And as we all know, one formula, power is equal to voltage into current. Use Ohm's law here. V is equal to IR. So here it will become I square R. So students, here if current is increased, and as we all know, current remains same in series combination across each bulb. And if current is increased, then what will happen? This power will increase. So brightness of bulb will increase. So in this way, you have to relate all the things. Now next, out of three connecting wires in a household circuit, which of the two wires are at the same potential? So students, which of the two wires are at the same potential? So here, earth and neutral wire, they are the same potential. And next is, in which of the three wires should the switch be connected? Switch is always connected in line. Now next. Next is, a new electrician connected brown wire to the left cylinder, blue connected to the top cylinder, and yellow wire to the right cylinder of socket. Has he had a mistake? Can you correct him? So students, what are the color coding wire for earth, neutral, and live wire? So students, brown we use for brown we use for live wire, and blue we use for neutral wire, neutral wire, neutral, and yellow we use for earth, yellow we use for earth wire. So students, left terminal is which? Neutral wire. So left, for left it will be blue color, and top is earth. So top we will use yellow color wire, and students right, in right we connect live wire, so in right we will use brown wire. That's it. So in this way you have to write the solution. Now next. Now next students, they are asking two fused wires of the same length are rated 5 ampere and 20 ampere. Which of the two wire is thicker and why? So just thicker wire means they are talking about uh, greater width wire. Thin is a smaller width wire and thick is greater width wire. And students, if there is thick wire, it means area of cross section is what? Area of cross section is bigger. Area of cross section is bigger. And as we all know, resistance is inversely proportional to area of cross section. If A is bigger, then what will happen? R will be smaller. And if R will be smaller, current will be higher. So here, which is higher current? 20 ampere. So students, for thicker wire, we will use wire of current rating 20 amp. So in this way you have to solve this. So now next is students, why do you transmit alternating current at high voltage? Students, I have taught this in class. Why we transmit alternating voltage at high voltage? So then simple reason is at high voltage, uh, current is small, and student we actually we need when we are transmitting alternating current, we need there should be less heating effect in the wire. So for less heating effect, what we need? Low current we need. Is this clear? So students, uh, for this region we transmit alternating current at high voltage. Now the next is the reverse side of a 3-pin plug with incorrect connection of wires is shown in the figure below. It is a reverse side. Is this clear? Not front side, it is reverse side. So here, uh, as you as you will see here, this blue wire and this is reverse side, so it should be right, not left. It should be right and it should be left. Is this clear? And it should be top. So as you all know, current coding, color coding of wires, so you can solve this problem. I'm not going in detail. Now, friends, next is in the transmission of power, the voltage of power generated at the generating station is stepped from 11 kilovolt to 130 kilovolt before it is transmitted. Why? So, friends, this is simply given in the book. So you can just see voltage is high because we need less current. If we will get less current, there will be less heating effect in the wire. So there will be less heat energy lost in the form of heat will be in the wires. Let's do this. Now, sir, next is next problem. State the potential difference and frequency for domestic electrical energy. What is potential domestic potential difference? 220 volt. And what is frequency? 50 hertz. This is also very simple. Next is two bulbs are marked 60 watt 220 volt and 60 watt 110 volt. Find the ratio of their resistance. So students, we have to find the ratio of the resistances. So students, as we all know, power is equal to voltage into current. And students, we need resistance, so we will replace current. I is equal to V by R. So here P will become how much? P will become V square by R. So here R will become how much? V square by P. Here will be V square by P. So students, we will calculate resistance for first bulb. So here R1 will be equal to how much? V square, V1 square, power is same. So I will take it as by P. So here R1 will become how much? 220 volt into 220 volt upon power is how much? 60 watt. And resistance R2 will become how much? If you will calculate 110 volt into 110 volt upon how much? Power is 60 watt. And we have to take the ratio of two resistances. So here if you will take the ratio of two resistances, so how much it will become? R1 upon R2 will be equal to 220 volt into 220 volt upon 60 watt, and R2 will become how much? Here 60 watt upon 110 volt into 110 volt. So here if you will calculate this, it will go by 2 It will also go by 2. It will also go by 2 and 60 will go by 60. So here you will get R1 upon R2. It will be equal to how much? 4 upon 1. So here the ratio of R1 and R2 will be equal to how much? 4 is to 1. So in this way you have to solve it. Here next is students. Write the color coding of the wire connected to left of the three pin. Children, this is also very simple. It is straightly given in the book. You can see. I'm not going in detail. Why earth pin is longer and thicker in a 3-pin plug? This is also given in the book and I have taught in the class. Why it is longer and thicker? Because we need our first connection to the earth terminal. Why? Because students, if however by some means if there is extra current in our circuit, then what will happen? Uh, that extra current will travel through the earth terminal straight to the ground, and you will not feel electric shock. So this region you have to write in the exam. Now, so next, find the cost of running 560 lamps and 400-watt fans for 8 hours if electrical energy cost is 2 rupees per unit. So students, here 560-watt lamps and 400-watt fans. So total power will become how much? Total power, it will become how many lamps are there? 5. 5 into 60 watt plus how many fans are? 400-watt fans. So here it will be 4 into 100. So here if you will calculate this, 65 by 300 plus 400, 700 watt. So here we are getting 700 watt. This is total power. And students, it is used for 8 hours. So here we have to calculate the electrical energy cost. So for this, we need electrical energy consumed in the unit, in which unit? Kilowatt hour. So here, this is in watt. So here 700 watt into, for how many time we are using? We are using for 8 hours. 8 hours. Now, friends, we need is kilowatt hour. So what we will do? We will divide by 1000. Kilowatt into 8 hour upon 1000. Is clear? So here 56 upon 10, 5.6 kilowatt hour. Now, students, for cost, electrical energy cost 2 rupees per unit. Unit means kilowatt hour. So here, students, it will become 5.6 kilowatt hour into 2 rupees per kilowatt hour. So here, how much you will get? So students, here you will get 11.2 rupees. Here you will get 11.2 rupees. So this is the solution of it. Now next. So this was all about 13 problems. Next we will let me upload here. So here students, fill in the blanks problem. QG device, it is used to limit the current. It works on the principle of heating effect, Joule's heating effect. It is made of an alloy of tin and lead, and it has two characteristics. It has low melting point and high resistivity. And fuse wire, it is always connected in series with live wire. This all we have studied in detail. Now next is students, a heater coil is cut into two equal parts. and one part is now used in the heater. The heat generated will now, assuming potential differences, same in the circuit. So students, a heater coil is cut into two equal parts and only one part is used. So here length is becoming how much? L dash. It is equal to L by 2. And students, as we all know, resistance is directly proportional to length of the wire or length of the conductor. So if length has become half, then resistance will become how much? Resistance will also become half. Calculate current, potential difference is same. So here current will become how much? V by R dash. So current will become 2V by R. And what is heating effect? H is equal to I square RT. So here students, current will become how much? 4 V square uh, by R square. Let it be R dash. Resistance has become how much? Half R by 2. And time is same as it is. So here it will become 2. Again, write it in terms of current. It will be H dash. H dash is equal to 2 V square by R square into R into T. So here H dash will become how much? 2. It is I square. It is R. It is T. So heat energy has become how much? It is double. So in this way you have to solve this. So be careful while solving the problem. So it will become double. Next, 16. So they are asking 16. So in the 16, they are asking, write the names of the equipment mentioned in X and Y in the following figure. X is what? Electric meter, and Y is what? Main switch. What will consequence if we connect fuse in the neutral wire? Then what will happen? So students, if we will connect fuse in the neutral wire, then what will happen? There will be current. There will still be current in the circuit, and you can feel it. Sure. I have taught in detail in the class also. A fuse is rated 5 ampere. Can it be used with a geyser rated 1540 watt to 220 volt? Yes, yeah, right, yes or no. Give justification for your answer. Uh, just see. The rating of fuse is 5 ampere, and they are asking can it be used with a geyser rated 1540 watt 220 volt. So yeah, power is equal to how much? Voltage into current. So current is equal to how much? Power upon voltage. Now friends, here power is how much? 1540 watt, 1540 watt, and voltage is how much? 220 volt. So here 0, 22, 7 J, 154. So here we are getting current as 7 ampere. And students, the rating of fuse is how much? 5 ampere. Is this clear? So if we will use this in geyser, then what will happen? Then what will happen? Because then what will happen here, students? The rating of current in geyser is 7 ampere, and if you use fuse of 5 ampere current rating, then what will happen? Due to excess current, fuse wire will melt and your circuit will be disconnected. This region you have to write in the exam. Now, the next they are asking uh, two bulbs of rating 220 volt 100 watt and 220 volt 60 watt are connected in series. If they are and students, if they are connected in series, which one will glow brighter? So you have to tell if they are connected in series combination, then which one will glow brighter? So students, first for this, we will calculate first current. How to, sorry, don't calculate current. For this, calculate resistance. Calculate first resistance. So here friends, resistance is how much? R1 is equal to V square upon P1. Voltage is 220 volt, power is 100 watt. So here it will be 220 volt into 220 volt. Power is how much? 100 watt. So here 0, 0, 0, 0. So here we are getting resistance as how much? 484 ohm. And here friends, we'll calculate resistance for second bulb. R2 is equal to V square by P. So here it will become 220 volt into 220 volt upon power is how much? 60 watt. So here it will become 60 watt. And friends, if you will calculate this resistance, we will get the resistance approx 807. Is this clear? So resistance for first bulb is 484 ohm. Resistance for second bulb is 807 ohm. Now then, what next we have to see, as we all know the relation between power, current, and resistance, which is how much? I square R. So students, these two bulbs are connected in series combination. So current will be same. So students, that bulb will glow brighter for which the value of resistance is greater. The value of resistance is greater for which bulb? It is greater for second bulb because it is coming out to be 807 ohm. So power will be greater for that. So that bulb will glow brighter. So which bulb will glow brighter here, students? This 60 watt bulb will glow brighter because we are getting resistance as 807. Is this clear? So in this way you have to solve this. Now next. Next is students, bulb A rated 160 watt, 40 volt. Bulb B rated 40 watt, 40 volt are connected as shown in the diagram. You have to calculate the ratio V1 is to V2. And in B part, they are asking if bulb A is fused, the current in the circuit remains the same. State true or false. So friends, first we will calculate voltage V1 and V2. So how to calculate? So students, first here, first we will calculate current for bulb A, that is I1. I1 is equal to how much? Power upon voltage. Power is how much? 160 watt. Voltage is how much? 40 volt. So here we will get how much? Current? 4 ampere. So current we have got 4 ampere. Calculate current for bulb B. So here if we will calculate current for bulb B, power is 40 watt, voltage is 40 volt. So here we will get how much? 1 ampere. So current we have got I1 as 4 ampere and I2 as 1 ampere. So students here, now next what we have to do, we have to calculate resistance for bulb A. How to calculate resistance for bulb A? R1 is equal to V square upon P1. To calculate it, we will calculate. So here 40 into 40, power is how much? 160 watt. Check that. Yeah, disconnect. So here 44 ja and 410 ja. Here we will get 10 ohm. And resistance for bulb B, V square by P2. Here we will get 40 into 40. Voltage how much? 40 into 40 and power is 40 watt. So here 1. So here we are getting 40 ohm is the resistance. Now friends, we will apply Ohm's law. Voltage is equal to how much? I into R1 for first bulb. and voltage for second bulb I into R2. Students, why we are taking current I? Because these two bulbs are connected in series combination. You will see in the problem, they are connected in series combination. So current will be same. So here students, V1 upon V2, you have to take the ratio of voltage, it will become R1 upon R2. R1 we are getting how much? R1 we are getting, you will see 10 ohm, and R2 is 40 ohm, 10 ohm, and 40 ohm, 1 upon 4, 1 is to 4. This is the ratio. Now when they are next, in the next problem they are asking, if the bulb A fuses, will the current in the circuit remains the same? Is it true or false? So it will be false. Because if one bulb will fuse, then what will happen? The circuit will break and no current will flow. No current will. So this was the solution of this. And if you have liked my problem solving technique, then you can like, share, and subscribe my channel. That's all.